What's going on, everyone? Welcome back to my channel. In today's video, we are talking about how to go from a beginner Python programmer to an intermediate Python programmer. Some of the things that we are going to be working on today are your project structure, the data structures that you're using within your code, and also how you think about designing the classes, objects, functions within your code. This is the second video in this series, and you don't necessarily need to see the first video, but if you want to get up to speed and learn some of the lessons that we covered in that first video, then I do recommend it. But if you are just starting out here, that's fine. We haven't made a lot of progress on our application. The application that we're working on in this series is a patient manager system. If you're interested in advancing your Python skills and learning how to build real-world applications with the Python programming language, be sure to like this video and subscribe to my channel. All right, let's just jump into the code and start improving our application. This is what we have here so far. We have our patient manager. I think in the first video it was called like Heart Patient Manager. I changed it to just Patient Manager. So this is the root directory. We also just have one file. We started this application just building out one file. What you can see here is that we have a patient class, we have a few functions, and we also have these compute classes down here at the bottom. The functions encapsulate the use cases of our application. So far, we just have two use cases. We want to be able to retrieve a patient from a set of patients, and we also want to be able to retrieve attributes from a patient. And some of the attributes that we are going to be retrieving from a patient are not necessarily stored within the patient. We have to compute those attributes. And that's where this compute class comes in. This class encapsulates the functionality for computing attributes from a patient. And this specific patient's compute class is meant to encapsulate the logic of computing an attribute for a specific patient based on some features of the total collection of patients. All right, so we are ready to start implementing changes to our code. The first thing that I'm going to do is I'm going to create a branch for this code. I'm not necessarily using best software engineering practices with what I'm about to do with Git. The main reason why I'm going to create these branches is so that you can easily go to the code as it was at the end of each of the tutorials, because the code will be its own separate branch. So the command that I'm going to run is git checkout b, and I'm going to call it tutorial 1. This creates and switches to that new branch. I guess I really didn't need to switch to it because now I want to run git checkout master. I'm going to go back to the master branch. And now we can see if I run git branch, we have master and tutorial 1. So by the end of this video, I will create a second branch called tutorial 2. And then if somebody wanted to go back to one of these tutorials and try to implement everything that we did, then they can just go and get the branch. All right, now that that's taken care of, let's structure our package. I'm going to show you one of my favorite Python packages. This is called Dask, and I want to show you the structure that they have for their package. One of the reasons why I'm showing this specific package is because they've structured it as many of the Python packages out there do. So this is a very common pattern. So the main things that I want to show you in this root directory are that we have a directory within this root directory called Dask. And if we click into Dask, here we can see a few other directories as well as a bunch of Python files. We also see this init.py, this __init__.py. This is a very important file. This file basically tells the Python interpreter that this is a package. This is a Python package. Having this file within a package allows you to import the contents of that package into other Python scripts. If we dive into one of these packages, we can see that they are doing relative imports. They're using this dot notation, which just means in the current directory, the file called callbacks, import callback. This functionality is made possible by having that init file. Now let's jump back out to the root directory so we can see that the core Python package is actually its own directory within the root directory. And on the outside, there are things like the README, the license, and most importantly, the setup.py. This setup.py makes the package installable. So these are just some of the things that we need to be aware of and that we will use when we are structuring our package here. What I'm going to do is I'm going to create a new Python directory, or Python package, sorry. We'll just give this the same name. We'll call it Patient Manager. And what PyCharm does is just add that init file right off the bat when you create a Python pack. Now I'm going to move my manager.py into the patient manager. And normally we would just want to go through this and make sure if any of the files that we had, if the paths changed or anything like that. But in our case, nothing changes. And even if it did, PyCharm would just update it automatically. But I did an absolute path for our data path here. Down the bottom here, we have this little script. So if I just run this file, I do get an error when I run this, but it's related to the fact that I moved this package. So it's not related to anything that I just did. It's just something that I did on my personal system. So let's try running this again. And I changed the name from heart patient to patient manager. All right, there we go. Now the code is working again. Okay, the next thing that we are going to do is let's add some files. Typically, a good rule of thumb in all of Python is to have flat structures instead of deeply nested structures. What I mean by that is that when you go to structure your Python package or just Python code, try to avoid overcomplicating the code with deeply nested directory structures and things like that. Instead, just have a flat structure. You can just have a number of files at the root directory. If it really makes sense to create a second package or sub package, then you can do that, but it should make sense. Like, there should be some reason for doing it. I think it's better to not spend too much time over analyzing the structure of your package. And what I like to do is just evolve it over time. So I like to work in just a single file until the complexity starts to become too much and I start to see some patterns emerging, and then I start shifting out different parts of it into their own file. What we are going to do is we are going to create a file called models. Instead of creating a file called patients where we're going to just shift over this patient, we're going to call it models, and we're going to keep any class data structure in there. So this is an abstract data structure. It's really just meant to represent some data within our system, an object within our system. We're going to keep that over in our models file. Now we go back over to manager. Still in manager, we have the logic of our application. This is where the logic of our application is going to live. And I want to keep it that way. But one of the things that we're going to do today is we are going to create a class around this manager system. We're actually going to call this just class patient manager. So we're going to take some of these functions here and we're going to just shift them into our patient manager. Let's just take a step back for a second and look at the code that we have here on this file. We have this hard-coded data path. We have a few different functions which encapsulate our use cases. Let's ignore these compute classes for a second. And then we have our script down here where we're just like testing out the functionality of our application. What we are going to do now is take all of the logic related to the patient manager system and put it into its own class. So we went from this Python file to a Python class. And really that's kind of how Python is set up. You could think of your code within a file as kind of like the code within a class. It's just that once we restructure that code into a class, now it's easier to work with that code as a single object. So now our patient manager is going to be an object within our application and not just the contents of a file. One of the things that I had mentioned before is this data path. Let's actually put this into our patient manager system. We'll pass it as a parameter. We'll just call it path. This is going to be the path to our data. For now, I will just store this path as an attribute of our patient manager, but we don't actually care about the path that much. We want the contents of the path, at least as our system is currently constructed. So let's see if we can modify this a little bit to see if we can store the actual contents of the path within our patient manager, the thing that we actually care about. In order to do that, let's shift over this get patient data into our patient class. We need to just modify this function by adding a self parameter to the method. And because I really don't want to store the path within our patient manager, we will still pass this in as a parameter. Notice that this function is returning patients. So what we're going to do here is we want to store the patients. So let's do self.patients equals self.getPatientData, and we are passing in that path. Now running this method is going to return our patients, and patients are the thing that we want to store on our patient manager. Since we moved our patient class out of this file, we need to import that patient class. Personally, I've had a lot of difficulty using relative imports, and I think the simplest solution is just to do imports from the name of the package that you are in. So in this case, our package name is patient manager. When I'm running this import, I'm doing from patient manager dot models import patient. Patient is our patient class. So now we have our patient manager class, and let's look at our two other functions here. We have find patient and get patient attribute. It makes sense to have this find patient within our patient manager. So let's just shift this over and modify this function so that it can be a method within our class. We no longer need to pass in patients because we are storing patients within our class. So let's do return self.patients and get the value of the unique ID within our patients dictionary. If you didn't follow the first tutorial, patients are stored as a dictionary within our system right now. Okay, this code looks pretty good, but now our script down here at the bottom is broken. And the nice thing about having the script is that you could just run this code, and if it's broken, you can see, okay, there's something wrong with my code. I need to go fix it. So every time you're making changes, you can just run this script and see if the expected behavior is still maintained within your system. One of the things that we can do in our code base right here is actually just extract this script out and treat it as a test within our system. There are adherents to a specific software engineering practice called test-driven development, where you write out your test before actually implementing any of the code for your system. And the rationale behind this is that by writing the test, you identify the use cases, you identify how the code is supposed to work, and then you have something to test your code against to see if it's actually meeting the requirements that you set out to implement. Test-driven development is kind of a polarizing subject, and there are other people that just don't write any test. What I like to do is loose testing, where I just write these scripts and think about the API of the system that I'm building. As your system and your needs evolve, so should your code. So at this point, we can just add some structure to our package to include tests. Let's create a directory within our patient manager Python package. There are actually two ways that you can structure your test. You can put your test in the Python package, as I did here, or you can put your test in the root directory. I've seen both done. The important thing is that your test should run with the code that is expected to be shipped. So if a user downloads your code to contribute to it, to add to it, to evolve it, they should be able to go into the test and run them and get those tests to pass. So your tests need to include anything that is required to get those tests to pass. All right, and now within here, I mainly just want this to be able to run my code. And I'm just gonna call this test because we just have very few tests at this point. I'm going to take out this script here and let's add this into our test. All right, so we need to do our imports and we need to fix this script. And now we can take out our hard-coded data path. And this hard-coded data path is only something that exists within our test. It's not going to exist within our main application because really we want to parameterize that. We want that to be something that is passed into the code, into the system, and our system will run with any patient manager data. It just needs to be in the expected format. Now we need to instantiate a patient manager. I'm just going to call it PM, patient manager, and we pass in that data path. This method is now called automatically, and our patients are stored within our patient manager class. Find patient is a method on our patient manager, and we no longer need to pass in patients. These computation steps here are really meant for a different test. So let's take that out. We're gonna run our code, and I want to print the attributes of the patient that we get. We're just gonna run vars on the patient class, and this should print out a dictionary of the attributes of that patient class. So let's run test manager. Oh, and actually PyTest is set up and it's running now. So you can see like this is how PyTest works. It's going to run each of the tests that we've defined. When you set up PyTest, you have to name your functions as test underscore whatever. I also thought that your file needs a specific name. I thought it needed to be test something, but maybe that's not true. But you definitely need your test functions to be test underscore something. All right, let's look at this, the output here. For future reference, when we run this test, we always expect this patient to have these attributes. So let's just see if this will work. Oftentimes, tests are run with this assert statement. So in this case, we would do assert vars p equals or equals this. And it's kind of ugly, but for now I just want to see if this is going to run successfully. Okay, it runs successfully. Maybe we can make this look a little bit prettier. All right, so we wrote our first test for our code, and now we can just, anytime we want to see if this code works, we can run it. I don't even think we need to call the function. Let's see if this will run. Yeah, that will run too. So PyTest will just go through and grab all the functions that are named test underscore something, and it's going to run them. All right, so we just built tests within our system. Now let's go back over to our manager and continue restructuring this code a little bit. Let's create another file called analysis. This is where we are going to store our compute classes. And the one other thing that we have to do something with is this get patient attribute. I've thought a little bit about this function. I've considered moving it as a method within our get patient class, but then it starts to resemble so much the built-in functionality for getting an attribute from a class. I think that the use case for this function right now doesn't really warrant that move into being a method of the class. Instead, I see it as a part of our API. It's a function that we are going to call on the patient class. But it's not necessarily something that makes sense to me at this point to move into our patient class and take away from the fact that our patient class really is just a data class. So for now, I'm going to keep this as just a standalone function. I am going to move it to the top though, just because as a reader of this code, if I just see a class, I might think that that's primarily what this file is for and might not easily notice this get patient attribute. And I think it does make sense to keep this in the manager part of our class because overall, this is part of the business logic of our application. We'll see how this code evolves over time, and there might be a good reason to move this function elsewhere. But for now, this is what we're going to do. All right, there are two other things that I want to do in this video here today. So far, we've talked about the structure of our application, and we've gone through and restructured our code. And now we are going to continue on a similar vein and dive into this patient class. This patient class is essentially just a store holder of information. It's a way of allowing us to work with this information as a Python object, and it makes our code more Pythonic. But the syntax of this code, reading this code as it is right now, is not great. And Python has recently introduced something to help with these specific types of classes. This concept is called a data class. A data class is just a normal class with some specific behaviors to help in an exact situation like this. So let me show you how a data class works. First, we have to import data class. So we're going to do from data classes import, oh, I think it's capital, no, data class. It's kind of even difficult to talk about what a data class is because really it just works as a decorator. So we're going to use data class, this data class decorator. I was writing decorator. We apply this decorator to our class, and now this decorator is going to transform this class into a data class. I mean, those are the words that I'm using, but really it's just a normal class. What's going to happen is that this data class decorator is actually going to generate code for the class. And if you don't know, these decorators are the first thing that runs when your Python code is imported. So the first thing that our Python code is going to do is going to go through and run this decorator. So immediately when we import a patient into a running instance of a Python interpreter, then this data class is going to be run on the patient class, and it's going to produce a new patient class with some generated code. And one of the things that is generated is an init method. So we no longer need this init method. So I just delete all of that. Okay, now I don't want to bore you with typing everything out, so I already have it here. So this is essentially what we do now. Now we have these as variables within our class. You don't even need to set them equal to anything, but I do believe that the typing is necessary. So in order to work with data classes, you need to have some idea of typing in Python. And Python does not have a strict type system. So if you're used to type systems from other programming languages, Python's type system does not work the same way. It's kind of like suggested types because they're not enforced at all. But in order to write this data class, it seems like we do in fact need these types. If you know a way around this, leave it in the comment below. Like maybe maybe if we set it equal to something, yeah, so maybe you can, if you have a default value, then it seems like you might be able to escape the types. But if you don't have default values, then you need to add in the type. And if you want default values and the type, if you kind of like working with types, because it makes the code more readable, honestly, then here's how you do default values. You would set equal to 0. But of course, you can't do this actually, because you can't have something set equal to something within a class, within your init method, and then have other parameters that do not have a default value. So all your default values need to go last. You would need to restructure your code if you wanted to have age have a default value. You need to put it at the bottom. But in our case, we don't need any default values, at least not at this point. But now this code looks a lot more readable. Let's just go back and look at this is what the code used to look like, and now this is what it now looks like. All right, let's try running our tests and just make sure that everything still works properly. And yes, our tests are still passing. So we've modified our code, we've modified the patient class and made it into a data class, and the code still works. In general, a good time to use these data classes are when your classes are really just some abstract data type and you're storing data within a Python object. I've seen a few code bases where data classes are just spread out all over the place. And in my mind, I haven't really come up with a good set of rules for a time to use data classes and a time to not use data class. So I guess the pattern that I kind of follow is that I use data classes when a class is strictly meant to store data. The final thing that we are going to do in this video today is we are going to modify the data structure of the patients that is stored within the patient manager. Right now, our patients are structured as a dictionary of patient objects. We are modifying and developing this code base as a data-intensive application. We are going to be performing computation on the fly across our entire data set. Doing these types of computation on an in-memory data structure that has a bunch of Python objects is going to have a lot of overhead to it. You might have heard that Python is a good data analysis, data scientist, scientific computing, programming language. But you might have also heard that Python is a slow language because it is interpreted. But really, there's a reason why Python is so good at doing these data-intensive computations. And that's because Python acts as an interface to well-optimized low-level code. This low-level code is usually written in C, but it can also be written in a language like Fortran or any language that has Python bindings. So the intention of Python has always been as a glue language. You write the core parts of your computation in low-level, highly optimized code, and then you use Python as this high-level scripting language to glue these pieces of code together and build a system on top of it. So in Python, there are some very well-known packages that we can use that have these highly optimized data structures that we can use to perform computation within data-intensive applications. One such package is called Pandas. I already have Pandas installed in my environment. And the typical way of importing Pandas is with this statement here. Import Pandas as PD. Because now we can work with Pandas as just PD. When I was a beginner Python programmer, I knew about these packages like Pandas and NumPy, and I was always curious when to use them. When was the best time to use these packages, and how do you learn these packages? What I have found is that the best time to learn anything is when you need it, when you have a use case for it. So understanding the use case behind these packages, or at least some of the use cases, will help you in identifying when to use them. The core part of Pandas is a data structure known as a data frame. And just as a dictionary is a data structure within Python, so is a data frame. It just has a different set of use cases. What we are going to do here is we are going to convert our patient's data into a data frame. This will allow us to use the built-in methods within the Pandas data frame class to perform computation on our data. A data frame is like a giant data table. It's like an Excel spreadsheet, except you have access to a variety of computations that you can do simply within the Python programming language through the API of the Pandas data frame. Pandas also has a bunch of built-in functionality for converting specific data types into a data frame and also converting a data frame into a variety of data types. By data types, I mean persisted data, so you can convert it into specific file formats, or you can even convert it to other data structures in memory, like a Python dictionary. So if there ever is a need for getting a dictionary of all of your records within a Pandas data frame, then you can very easily do that using the Pandas API. All right, so let's convert our code so that we can use a Pandas data frame. The first thing that we are going to need to do is go right into this get patient data, because this is where we are actually extracting the data from our data set. And now we don't need any of this logic. And if you knew how to use Pandas before, you might have seen me doing this and been like, oh wow, he should have just used Pandas. And yeah, I totally agree. So here's what we're going to do. We are going to create a data frame. It's going to be a patient's data frame. I'm going to call it PDF. The way that we're going to do this is we're going to run pd, which is our pandas, dot read CSV, and then we need to pass in the path. There are a bunch of other parameters that we can pass in as well to this read CSV, but right now we don't have any way of passing those parameters down into this get patient data method. And it does seem like there's a pretty good reason for being able to pass these parameters. We basically have two options. We can either have very strict definitions of the data set that we have, like it has to be structured in a very specific way, or we can give the user access to passing in other parameters to this read CSV. In this case, I think I'm in favor of passing in the parameters to this read CSV. So let's modify our class a little bit just to make that possible. We are going to pass in keywords, which means that we need keywords up here. By definition of our function, these keywords are going to be keywords for this read CSV. I could go and like specifically identify that by saying like CSV keywords, but I think that kind of looks awkward. And the usual Python syntax is just to use keywords. And the other thing that I want to do here is I want to actually make this a class method. So I'm going to change self to class, and we are just going to return a PDF, patient data frame. The usual syntax is df, and I think it just kind of makes sense to just use df because it's just a data frame. So we are returning a data frame. And now this method is not get patient data, it's get patient data frame, or maybe we can just call it get data frame. Okay, so now we need to make a few other modifications to our code here. For the use cases that we have where we are getting a patient from our system and also getting attributes from our system, there really isn't a strong need for storing the patients in memory just to get a patient out of this in-memory data structure. It makes sense to have the patients in memory if we're performing computation on it. But if we just need to get a patient, there's probably better ways of doing that, like storing our patients in a database. Eventually, that's what we're going to do. We're going to evolve this code to use a database. But for right now, just to get this code working, I'm going to treat patients as the data frame. But I'm not going to design my code around storing the patients as a data frame, because eventually I'm going to evolve out of that. But what I am going to do is I'm just going to call the class method. So in order to call a class method, you call it on the class itself. Patient manager dot get data frame. We want to pass in the path. And for right now, I'm going to add keywords here, and these will be the keywords for the data frame, but eventually I don't want that. I don't want the keywords for the data frame being passed into the init method, because now for the init method, it's really not clear that these keywords are for this CSV, the read CSV function. But in order to get this code to work, we are going to do things this way just for now. Let's try running our test again. Our test is failing. We are not getting the appropriate response from our test. And that's because we haven't modified our find patient function yet. All right, again, this is definitely not the best way of doing this. We probably lose a little bit on performance by doing our lookups in this way, but here's the code for doing our patient lookup. We're going to run a query on the data frame. This is a built-in method of Pandas, and we want where the ID is equal to the unique ID. this is going to return a new data frame, patient data frame. What we are going to get from this method call here is a list of dictionaries for each record. And we want to just grab the first one. There should only be one anyway, so we're just going to grab the first one. That's our patient dictionary. Now we want to instantiate the patient class with this dictionary, and we are returning a patient. So now our test should pass again. And yes, look at that. Our test is passing once again. So again, we probably lost a little bit on the performance because before we were just indexing into a single dictionary, but we did this in order to gain in performance elsewhere in our code as we start to ramp up the computations that we are doing across all of our patients' data structure. And for this find patient functionality, we are eventually going to be implementing this in a database. So this is just a short-term hack to keep our code working. But notice that the tests still work fine. We changed the underlying implementation, but the top level API still worked just as expected. And that was one of the points that I was trying to illustrate in the first video. All right, we've done a lot in this video so far, and I think that this is a good time to call it wraps. In the next video, we will focus on our computations class. I think it makes sense to dedicate that entire video to just thinking more deeply about the different types of computations that we can do within our system and how we can really leverage the Pandas data frame and some of the other built-in functionality within Python for doing scientific computing. Be sure to hit the like button, subscribe to the channel, and I will see you next time.